Alright, welcome back. The last couple of videos we've been setting ourselves up for today's lesson and today's activity. The first thing we've discussed is three system variables using substitution. The second thing we've discussed is using row operations to simplify matrices. Today we're going to put those two together in what is called Gaussian elimination. You notice that there are some matrix operations that we can do, and we can relate those back to the elimination process that we used a couple of days ago for systems of equations, linear combination, or elimination. You'll notice also that we have an end result that we're trying to meet, and that end result is going to mirror what it is that three system variables using substitution showed us. So the first operation that we've got to be able to embrace is multiplying any row by a non-zero scalar. That makes sense with two variable system using elimination, where we're trying to get the variables the same and getting one to cancel out. That is essentially what you're doing. So if you have x plus y, for example, and negative 2x plus y, you want to multiply the first equation by 2 so that you can get that x variable to cancel out. Switching any two rows means that we can put any order of rows that we want, or we can use any of the rows that we want in order to conduct our operations. I don't have to use 1 and 2, for example, because they're side by side each other. If I need 1 and 3, I can go ahead and switch those up and make that happen. I can add a multiple of a row to another to obtain a new row, and that is directly off of that elimination method once again. So the key to today's activity is finding that purpose, the purpose that we are actually going to get our second row to have a single zero in the first variable, and then our third row is going to have double zeros, or a zero in the first variable and a zero in the second variable. Remember, this is our constant matrix, or this is our coefficient matrix on this side of the line, and this is our constant matrix on this side of the line. We're going to take, instead of writing two different matrices, a single one, and that's how we're going to progress into this new system of Gaussian elimination. So in question number 1, we're going to go ahead and take a look at it in all of its parts. So notice that we have these values in our augmented matrix. Notice that we've got a 0 in the first and a 0 in the first spot of the first, second, and third rows respectively. That means in order to get our matrix to look like this, we simply need to turn this into a 0 as well. The way that we're going to do that is by adding row 2 and row 3 together. The reason I'm going to do that is because there's a positive one here and a negative one there. By adding these two rows together, I will cancel this second variable out to make 0. So the row operation is defined here, and then the work for that is shown below. As a result, I'm going to see this new augmented matrix. Now in this particular example, I'm going to show you without using variables how this works, so that you can kind of get some ideas about what's going on. Remember, the first variable is x, according to this. The second variable is y, according to this. And the third variable is z, according to this. Remember that the matrix needs structure in order to work. So that means in this particular case, the value of z is 4. Now I'm going to go up to row 2, and I'm going to go ahead and utilize that information to figure out what y is. Since this is the y value and this is the z value, I'm going to multiply the z value times 2, and 2 times 4 is 8. Using PEMDAS, I'm going to subtract this to the other side, making 10 minus 8 equals 2. So y is 2 in this particular case. Now I'm going to go up to row 1. Row 1 says that there's 1x plus 2y plus 1z equals 5. So I'm going to plug in those respective values, y equals 2, z equals 4, and that's going to give me a value of 13. No, sorry, excuse me. 4 plus 4, which is going to be 8. And then I'm going to subtract that to the other side, giving me the end result, x equals negative 3. So this is how we're going to use row operations to help us solve these problems. All right, let's go ahead and take a look at these so we can clearly identify what's going on. I'll zoom in so that we can focus our attention on one piece at a time, making it a little bit more clear on what we're looking at. In this particular case, you'll notice that what I'm trying to do here is I'm trying to identify this value and make it a 0. The way I'm going to do that is I'm going to apply row operations using row 1 and row 3. The reason I want to do that is because those two ones, if I subtract them from each other, will result in a 0 in the first place. So that's what you're looking for when you're trying to perform row operations. Now notice I put in 1, 2, 3, and 9 here. And notice I put 1, 4, negative 1, and negative 5 here. Because I'm subtracting, I put a minus sign across here, and these two negative values, when I subtracted them, became positive. The resulting row is going to be placed into row number 3. And now you'll notice that this and this are both 0, resulting in what I need in order to solve this problem. Now the next thing I'm going to do is I'm going to identify the third place where I need to have a 0. And that place is here. I'm going to have to use row 2. The reason I cannot use row 1, even though it looks enticing, is that if I were to subtract or even add row 1 and row 3, this 0 would not remain a 0 because 1 plus 0 becomes 1 again. That is the reason I have to use row 2 instead of using row 1 in my row operations. So once you change these two zeros, I am stuck now using whatever is in row number 2 to get my third value. Otherwise, this 0 will become a different number. So the row operation I'm going to complete is actually multiplying by a scalar, and that's going to be 2 because I need this 1 to be the same as this 2. And then I'll simply add them together because I have the positive and the negative value. So it's going to be 2 times row 2 plus row 3 is going to give me a new row 3. So distributing the 2 throughout gives me 2, 0, 2, negative 2, and negative 8. And then adding these to each other gives me 0, 0, 2, and 6. The new augmented matrix becomes this. And now you can see I have my 3 zeros in place, and I can utilize that substitution of variables as my ability in order to solve this. So what I've done here is I've gone ahead and looked at it in terms of what it would look like if the variables were back in place, because sometimes it gets a little bit confusing if I'm just using numbers. So you'll notice here that what I've got is 2z equals 6. I need to divide both sides by 2, and that gives me the value of z, which is 3. I'm going to do y minus 3 equals negative 4, add the 3 to both sides, and that's going to give me negative 1. Then I'm going to do x plus 2 times negative 1 plus 3 times 3 equals 9. So that's going to give me 9 minus 2, which is 7. And that's going to be x plus 7 equals 9. Subtracting 7 to both sides, x equals 2. Now I write it like this because that's the way we've seen it and that's the way it's consistent, so I just want to keep it that way for everybody as far as consistency is concerned. Okay? All right. Now what we're going to do is we're going to get into a little bit more complicated issues when it comes to solving these problems. Now we're going to check our solution using the calculator steps that are right here off to the side. So I want you to take a look at those right now, and we're going to go ahead and address that before we move on. So the first thing I want to do is I want to write in the original augmented matrix. That's going to be 1, 2, 3, 9, 0, 1, negative 1, negative, negative 1, negative 4, and then 1, 4, negative 1, negative 5. Now what I'm going to do is I'm going to bring up my calculator, and I'm going to go to the matrix. Now I've got a whole bunch of matrices in here, possibly more than you will have, and since these are already preloaded, I'm going to go down to matrix G. Feel free to use any matrix that you wish in order to do this. Be careful not to overwrite these because you'll still need them from time to time, so I just continue to write my list down. Now because I'm using a new matrix, I need to put in the new dimensions, so that's going to be 1, 2, 3 rows, 1, 2, 3, 4 columns. So that's 3 by 4. Now I'm just going to type in everything I see and go ahead and fill this all in. 1, 2, 3, 9. 0, 1, negative 1, negative 4, 0, 1, no, excuse me, my apologies, 1, 4, negative 1, negative 5, and then I'm going to quit out of the matrix. Go back to the matrix again and go to the math screen. Now I'm going to go down to the bottom and scroll up to find RREF, Reduce Row Echelon Format. I'm going to retrieve the matrix I just filled, that's matrix G, and now I'm going to fill in my answer. And you can see that I have 1, 1, 1. This signifies the value of the variable, so the x was in the first place, the y was in the second place, the z was in the third place, and those are the corresponding answers that go along with it. This is the format of the answer you will always see. If these values are anything other than 1, you've made a mistake or something is wrong with your matrix. So just keep that in mind. This pattern will always emerge. Okay? Now before we use the calculator exclusively, we got to do some work in Gaussian, because you are expected to know how to use it appropriately, and so this will be our final example that we do before we practice with that calculator one more time. Okay, so the first thing you want to do is you want to rewrite your augmented matrix. Remember, the first 3 rows and the first 3 columns are going to be your coefficients on the left side of the equation. Remember, your final column is going to be the constants on the right side of your equation. We've got to do some identifying here. We need to identify the value that we need to turn into a 0. So I'm going to go ahead and change this 1 to a 0. And the way I'm going to do that is by subtracting row 1 from row 2, giving me a new row 2. The operations look like this, where I go ahead and fill them in. So subtraction, 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 subtraction results in this new row. I'm going to replace that row here. And following that, I'm going to identify my new place that I need to turn into a 0. And that would be this guy right here. I'm going to achieve that through row operations once again. Row 3 minus row 1, because those 1s will cancel each other out. The result looks like this, where this is minus, 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 and minus, giving me a resulting new row of 0, 2, negative 4, negative 14. Now I'm going to input that new row here into a new augmented matrix. And now that I've done that, I remember I'm stuck with the row operations between row 2 and row 3 because I can't change the value of 0 to any other number. So this one is going to involve that scalar, that multiplier that I need. And because this is a 2, that one needs to be a 2 also. Because of the sign change, now I can use addition. So we'll use two different steps here. The first one is to multiply that scalar. The second step is to add it to row 3. And the resulting row is this. And then I get a new augmented matrix that looks like this. From that I can fill in my final answers. I can find my solution quite easily. My solution, once again, is x, y, z, and that's going to be 2, negative 1, and 3. All right, finally, what we're going to do here is we're going to take a look at systems of equations, specifically utilizing the reduced row echelon format of the calculator. So I'll bring back up my calculator and we'll go through these steps one more time. You need to write your augmented matrix, so that's what I've done here. The next thing you need to do is you need to load your matrix so that you're ready to go. That's what I've done here in matrix number 5. Now clearly you can use the one from previous so you can see that. All right, so now you can see that I've loaded that properly and now we're ready to go. Second, matrix, go to the math, go down to reduced row echelon format, go back into the matrix, retrieve the matrix that you need, and in this case that's matrix number 5. And now I'm going to get my solution, which is x, y, z equals 35, 52, and 41. All right, question number 6. I'd like you to pause the video at this time. I'd like you to go through it and see if you can come up with the solution before I put it together in the last part of this sequence. So please take the moments right now to go ahead and do this so you can become comfortable doing this on your own. All right, question number 6. Hopefully you've written out your augmented matrix, which looks like that. The next thing you're going to do is you're going to go into the matrix, go to your math key. Hopefully you've gone ahead and filled in your matrix in your calculator already. Reduced row echelon format. My matrix is matrix F, and the solution that you get is 2, negative 12, negative 4, and 1. Please take the time to become familiar with both the algebraic steps of Gaussian elimination as well as the reduced row echelon format, which is in the calculator. If you have any questions, please feel free to ask, as there probably will be a few, especially on the row operations.